Okay, welcome back. We're at 2.5 now. So section 2.5 is compound inequalities. Now they're taking what we learned, and you'll see the way the textbook is set up. Each section builds upon an idea from the section before, basically, most of the time. Sometimes they'll throw something at us out of the blue. But we learned inequalities. Now we're learning compound inequalities. Once you know an inequality, when they give you a compound inequality, it just means we're dealing with more than one on a number line. So I don't really have anything to explain much before we get in. I think the easiest way with the next couple sections is just jumping into the actual examples or problem sets. So I'll share my screen, and the comment I made for section 2.5, if we see the word or, that's where they're talking about a union, and we want to graph all the points on either graph. If we see and, that's where they want us to know the intersection, which is just the points that they share, that they have in common. Then they will talk about continued inequalities, open interval, closed interval. You'll just understand what happens when you solve the problem and see where the x lies or the y. Okay, so I think it's best to just jump in to the problems. I'm only going to do 2. I actually only assigned 7 total problems out of this section. I just want you to have an understanding. So I am only going to do number 11 and number 18. So number 11 gives us 0.5. I chose this one because I know a lot of people really dislike decimals. I would rather have fractions than decimals. 0.3a minus 0.7 less than equal to 1.1. Now I think these are kind of fun. What I'm going to do right away on this one, we talked about fractions and getting rid of fractions, but we can also talk about decimals because they get kind of hairy. I'm just going to multiply, I'll put it here, I'm going to multiply this whole quantity, everything in there by 10, because I have one decimal point, one decimal place, one decimal place. If I multiply everything by 10, then I have the same proportion. Whoops. 0.5, 0.3, 0.7, 1.1, that is going to be the same answer as 5, 3, 7, 11. So I just increased them all by 10, made them all bigger by 10. So what we do when we have, let me do this one long, since I'm only doing 2 of these. What we do, I'll put it over here. What we do is 2 of these. I'm going to show you how it's easier to just do them together. We have to solve this one first, or second, whatever. We have to solve this one. And we also have to solve this piece. We have to solve 2 pieces. So what we do is, again, I still like keeping a positive variable if I can. You're going to see the way this is set up because it's in between. Sometimes it's actually easier to go to switch the sign route. But what I do here is I'm going to add 7. So let's just work this side, and then I'll show you how much easier it is to do it a different way. I'm going to subtract or add 7 to get rid of it here. So that gives me 12 less than equal to 3a. Then I need to divide by 3. I get 4 less than or equal to a. A is greater than or equal to 4. That's one answer. Over here, I have to add 7 to get rid of it. Look what I did here. I added 7. I'm doing the same thing, just to the 11. So now I have 3a less than or equal to 18. Well, now I divide by 3. Guess what? I did the same thing over here. I divided by 3. So I divide by 3. A is less than or equal to 6. So what I discovered is A is less than or equal to 6. So let's suppose that's 6. Let's suppose that's 4. A is less than or equal to 6. It's going that way. This one, A is greater than or equal to 4. Greater than or equal to 4, you're going that way. So for number 11, we want to write it out. I think it said, oh, it says use both a line graph and interval notation. So this is one part of the answer, the line graph. Interval notation tells us a is greater than or equal to 4. It can be 4, so I have a bracket. It's greater than, so it's going up this way. This side says it's less than or equal to 6. So I use a bracket because it could be 6, but it's less than or equal to. So this tells me my interval notation shows, hey, A is between 4 and 6. My line graph shows that A is between 4 and 6 as well. Now, I'm going to go back here because this is the way you want to do these. This proves the why, what you do. Well, you do the same thing to the left and the right. You just have a middle quantity in this case. So here's my middle quantity. I'm going to add 7 to get rid of it. I discovered I have to add 7 to the left and the right. Now we have a left, right, and a middle. To get rid of something from the middle, we apply it to the left and the right. So we can do it all at the same time. Now I get my 12 less than or equal to 3a less than or equal to 18. Then I say, okay, I got 3 a's in the middle. I need 1a in the middle. I have to divide both sides by 3 after I divide the middle. That gives me my 1a. Now you have your answer right there. You just have to rewrite it. Now you see it. A is between 4 and 6. When you leave it set up this way and just work with each side without splitting it, your answer falls right in. It tells you if you're in between two numbers. Okay. Then I think I'm going to do 18 because I only assigned you a few of these. I don't want to do 2 out of the 7 that I assigned. Number 18 relates to 17 and 19. So let me do number 18 real quick and we'll be done with this section and on to the next. Now we have an or. So that's different. Now we have an or. Now we're talking, it's going one way or the other. When it falls between, it's an and. It's, hey, A is between this and this. It's in the middle here. Now we have an or. The or tells us it's less than 1 going this way, but it's greater than 1 going this way, and there will be a gap in the middle. All right. Now that I blabbered, I got to get back on track. Now we can't do what I mentioned earlier. Now we have to do 2 separate problems. So I'm going to subtract my 2. That gives me 3x is less than -5. And sure enough, they give us an oddball number, and we're going to have a fraction. Doesn't really matter, though. Now I'm going to divide by 3. My x is less than -5/3. That's part of it. This one, I need to subtract 2, but now I have 3x is greater than 1. Now I divide by 3, and I find that x is greater than 1/3. Or, those are ors, because what happens here is, I have a -5/3. When you're doing your own number lines, don't worry about making a -5/3 fall in exactly the right spot. Just write it down and say, I don't know, it'd be over here somewhere. You can put, I'm going to put a 0 there. I don't care, whatever. I know it's up here somewhere. So when you're drawing your own line graph, just show this is what it means. If 5/3 or -5/3 is here, this is what my graph does. So -5/3 is here. We have less than. Less than means more negatives, getting smaller, and it's not equal. So we have a parenthesis, and it's going this way. So you can see it's just going to go that way for infinity. So less than, when you see a variable less than, you know you're working with infinite to the left. So -infinity to the left, and then -5/3. Less than, it doesn't include. This one, you were dealing with x is greater than all the way up. So you know that you're going up to infinity. It's greater than 1/3. 1/3 goes here, and no parenthesis. So I'm just going to say, well, if -5/3 was there, it'd be a little closer to make it somewhat accurate. I'll say 1/3 is over here. Probably should even been smaller, but I'm not grading you on that. I just want to see that you show me it goes up this way. So now there are my 2 answers. There's my line graph. and there's my interval notation. Those are the two, I think they were looking for line graph, then write each solution set using interval notation. Yeah, they wanted you to graph and use interval notation again. So here's interval notation. I have two of them. I have that or that, and then there's my line graph. And I believe that's all that I wanted to do. Yep, for 18. I did 11 and 18, two problems. You only have 7 total, well, 6 because I did 11, but I'd like you to do that one too. Now you have something to follow along. Those aren't too bad. Hopefully you enjoy those. Find the joy in this algebra for the semester. Okay, and I will see you back soon.